welcome to this session. In this session, we will be learning about the relational databases and overview of the database design. In the earlier sessions, we had seen about the DBMS overview and then models of databases, or else we can call them as the data models of DBMS. So, in the database, in the data models, we had studied about the hierarchical model, network model, relational model, then ERD, then object oriented model, and then semi structured model. So, the most popular data model among all these models is the relational model. So, let us talk about the relational databases and overview of the relational database design. So, the basic construct in the relational design is a relation. It consists of the relational schema and relation instance. Relational schema is nothing but the description of the table. Like suppose if you take the overall description of the table, like so what are the fields that it has, what is the name of the like relation schema. So, that represents the relation schema, and then relation instance is nothing but the table itself. So, relation instance is a table and relation schema is nothing but the description of the fields. Suppose if you take a table called as student, it has student ID, student name, course enrolled for, and then address 1, address 2, pin code and state. So, this particular student along with these fields or these attributes is called as the relational schema. So, this particular relation is nothing but the basic construct for all the relational databases. These relational databases are also called as record based model. Relation model is called as record based model too. So, definition is given on the slide. The relation database is based on the relational model and uses a collection of tables to represent both data and the relationships among those data. So, here whenever we talk about the relational database, we have to define that database name. Under that particular database, we have to create the tables. Suppose for a university, if you want to create the database, we have to give a database name. For example, university is the database name. Then under that particular database, we are creating interrelated tables. So, each and every table may or may not be in relation with the other tables. However, we find out, so which table is in relation with the other table. Then the basic construct or else the basic relational instance is called as a table, and each table has multiple columns. You can call them as the fields, attributes, whatever you want to say, and each column has a unique name. In the earlier example, for the student table, we had identified student ID, student name, course registered for, address 1, address 2, and then pin code and state. So, each and every column is called as a field and is having a unique name. Each table consists of records of a particular type. So, suppose if I provide the value for the student table, I have to provide the student ID number, then student name. Suppose 111 is the student ID, Rahul is the name, then course registered for is MCA, then Saket address 1, and then New Delhi address 2, and then we are giving the rest of the pin code 110068, and then state is Delhi. So, we had provided a value or else we had created a record. So, that is Rahul's record. Then comes another person we can enter. So, each and every record type defines a fixed number of fields or attributes, and each and every row we are providing is called as a record. The columns of the table correspond to the attributes of the record type. This is nothing but, suppose if you take the column student ID, that particular column, suppose if it is having 10 records, and that column student ID obviously tells you that this is the student IDs of all those 10 records. So, the column of the table correspond to the attributes of the record type. Let us see an example over here. Here we had created one table, and the table name is, let us think it is a student. We had provided student ID, student name, student age, student class, and then section. So, here the values are provided. SID, SName, SH, SClass, SSection, these labels are called as the columns, or else I can say it as attributes, or else field. So, for each and every field, whenever we are inputting the data, we have to see the column, what it should contain, and whenever we describe the column, we have to describe in the DDL statement, and during that particular declaration we have to put the data type also. Appropriate data type we have to assign to each and every attribute. Here student ID is there, and student ID in our example contains integers. So, the data type for student ID in the schema we had declared it as int. Like student name, varchar we had taken like variable character. So, that particular student name, the data type, the column name is SName, and the data type we had selected is the varchar. Maybe the size also we can select as 20, 25, whatever the case may be. Then student age, numeric, so we may select int, and then student class, and once again numeric, and student section is a character data type of only one single character. So, character of size 1, CHAR of 1. So, here each and every horizontal row is called as a record, or else you can call it as a tuple. Just see one example over here. The student ID 1104 is been highlighted. The complete set is called as a record, or else the complete thing is also called as a tuple. So, do not confuse with the column attribute, the row and the tuples. Both are, one is the vertical thing and the other one is the horizontal thing. Horizontal thing is called as the record. So, here I had given one simple example. The database schema we had designed. This database schema, suppose this schema is meant for one university. In this university, I want to have 4 tables. In this university database schema, I want to have 4 tables. For each and every table, the schema is defined, that is called as relational schema is defined. Department with number name, professor with number name, department number, courses, and then there is another table, course, number, department number, professor ID, unit, and then student ID, name and course. This is a simple database. The 4 tables constitutes a complete database schema of the university. So, individually whenever you want to create the database with the name, and then along with that particular database you have to create the tables interrelated with that particular database. Here there are 4 tables, and you can find the relation also. In this particular database schema, you can see some of the fields are common, like department number, department name is there, and then professor number, name, department number. So, here there is a relation, the table department and the professor table is having a relation. Professor is working in some department number with some department ID. So, there is a relation between the table department and the professor. Likewise, student enrolled for some course. So, both course and students, both the tables you are finding a relation. So, the common field course number or course ID is also telling about the relation between the course and the student. Then comes how to design these kinds of databases. So, just like that we can't design the whole database for a corporate or else a university or else for a library. So, there should be some stepwise procedure or process wherein which we have to design the database meticulously. So, there are 6 steps involved in the overall database design. The first step is the requirement analysis, conceptual database design, logical database design, schema, physical database design, security design. These are the prominent 6 steps one needs to follow in order to design a very good database for any organization. Let us see one by one in each and every step what are the tasks to do. First one is the requirement analysis. In this requirement analysis, one needs to understand what data to be stored in the database, what applications must be built on top of it, what operations are most frequent and subject to performance requirements, or else overall one can say what users want from the database, what they want. So, that is the requirement analysis. Suppose if you answer all these 4 questions, that is nothing but you had done the requirement analysis. So, what data is to be stored in the database? Depending upon the requirements, depending upon the applications that one needs to design top of it, we have to see what are the requirements. Suppose, for example, let us take the case of a library. When one walks into the library, one has to enter the details at the entrance. Like student, whenever he is walking into, he has to produce his log like student enrollment number, name, department and time when he is entering, and later on he will be moving to the desk. And then suppose if he wants the information of a book, he asks for, and if the book is available, the person will tell, the issuer will tell that the book is available, and then he can get that particular book issued. Or else he can move to the reference section, he can study, he can borrow a book, he can study and later on he can submit, or else the journal section he can move, or else he can go and see the archives, etc. So, there are various tasks a student can do. So, you have to see in order to optimize the library from the student's perspective, what are the requirements. Suppose for the faculty, once again some procedures may be same, some may be differing. No need of recording any log, maybe he has right away permission, he can go, he can ask for. For each and everything, the database should support. Like for students, when the university creates the database of the students, the library also should be in a position to access the student details. Whenever the faculty database is created, the library should be in a position to access the faculty database. The privileges part, that may be taken care to how much or to what extent of the data one can view at the library part. So, those things can be taken care. However, once the database, centralized database is created, one should have the access of the student records, faculty records. Then from the library point of view, one should maintain the records of the books. So, how many books are there, what are the various subjects, under category wise they have to mention. Like in the earlier we had seen the types of databases, wherein which we are talking about various source databases and other things. There, that is the list that one has to maintain for the source databases of the books. So book name, author, publication, volume number, year of publication, procurement, then ID, everything needs to be generated. Likewise, there are several things, several data to be taken care in order to fulfill the requirements of a library. So we have to answer this question very prominently, that what data is to be stored in the database. Then coming to the next part, that is the next layer, that is top upon it, what should be the interface in order to fetch the data, in order to retrieve the data, in order to see the information whenever we place the query. So what applications must be built on the top of it. So that also needs to be taken care. Depending upon that only we can design the database, the other things. And what are the frequent operations that one can do? So that also should be answered. And this particular process is an informal process. Like collecting the requirements is an informal process. You can go, you can have a site visit, or else you can get the information from the persons upon interviewing them, or else on-site observation may also can fulfill the requirement analysis thing. So this is completely an informal process, but understanding capability and capacity should be there. A study of the current operating environment and how it is expected to change, analysis of any available documentation, etc. that needs to be taken care. Suppose already there is a system existing over there, partial system existing over, you have to study that. Otherwise some manual thing is going on, you have to observe, you have to record the things. Otherwise some available documentation is present over there, you have to collect the documentation, you have to study it. So likewise this informal process continues and you have to answer all the 4 questions that are posed in the earlier slide. Next comes the conceptual database design. So earlier one is an informal thing, right now we are stepping into a kind of design, actual design. That too the preliminary part, what is called as the conceptual database design. The information gathered in the requirement analysis is the basis for this conceptual database design. This is used to develop a high level description of the data to be stored in the database along with the constraints that are known to hold over this data. So in the earlier session we were talking about the ER model. So using that entity relationship model, one can do the conceptual database design. This ER modeling is nothing but we are creating a plan, we are creating a blueprint for the actual design. So we are not straight away not designing the product, but we are trying to design the plan or we are trying to design the sketch. So this particular thing comes under the conceptual database design. Like for example, whatever the relational schema that we are going to design, for that we have to identify the entities. In the real world, we have to, real scenario, for example the library scenario, you have to identify the entities, like book is an entity, student is an entity, faculty is an entity, journal is an entity. So likewise you have to identify the entities and then you have to see the relation among the entity. You may find between all the entities or you may find with some of the entities. You have to identify all the relations among the entities as well as you have to identify the cardinality, like the type of relationship between each and every entity, whether it is one to one, it is one to many or many to many. So those particular things should be identified and should be drawn in the form of a ER model using the symbols that we had seen earlier. So that is the basis for the conceptual database design, and this particular blueprint or else the plan is going to be used for the logical database design, which we are going to see in the next slide. Logical database design, we must choose a DBMS to implement our database design and convert the conceptual DB design into a database schema. Like we had drawn the ER diagram, we had identified all the entities, we had identified the relations, and then right now we have to convert that particular ER diagram to the logical database design. That is nothing but here we are converting the ER model to the relational database schema. And this particular thing sometimes is called as the logical schema. For example, you had identified student entity. Under the student entity there are several attributes: student ID, name, then course registered for, etc. So those are the attributes of the student. Like student attends class. So once again class is an entity, and along with that particular entity you have the attributes too. So you have to convert that particular ER modeling to the relational database schema. For example, the schema will turn to student is the name of the schema, student schema. Then within brackets you have to identify student ID, comma, student name, comma, course registered for. So this is the type of conversion that we had done. And course also we will do similar kind of relational schema we design, and we identify the fields over there. Whenever there is a kind of relation between these two tables, we have to identify the similar columns also. So that is nothing but we are providing a kind of relation between the tables. Next comes the schema refinement phase. Schema refinement phase is nothing but we had done the ER modeling part and we had done the logical design part to analyze the collection of relational DB schema and then to identify potential problems and should be refined. This can be achieved through normalization process. So we had identified several relations. Along with that we had identified the descriptions. However, we have to once again have a look like how many relations are having data redundancy and other potential problems. So in order to address those problems, a procedure is there to sort out the tables from unnormalized to normalized ones. So that particular normalization is called, is nothing but the schema refinement. So there are several types of normalization procedures one needs to follow. First one is first normal form, second normal form, third normal form, BCNF, fourth normal form and fifth normal form. In later on sessions we will know about the normalization procedures. Let us move to the next phase called as the physical database design. So we must consider typical expected overloads that our database must support. In the physical database design, we are not at all concentrating on the plan part and other things. We are totally concentrating on the physical design part, actual design part, wherein which the table design and then the storage part is to be identified, and then indexes and clustering of some tables needs to be seen in this particular phase. So this is a crucial phase among all the phases. One needs to take very much care whenever we design the physical database design. One needs to go through the logical part, one needs to go through the conceptual part, then only you have to take appropriate physical database design. Later on comes the security design part. So the physical design part, the whole database has been designed, it has been done. However, you have to take the database security design part into consideration. This particular thing can be achieved by identifying the user groups and the roles played by them. Suppose if there are several roles starting from data entry operator till the director in any department, there are various privileges to each and every group. So identify the privileges for each and every group. Like data entry operator, he can enter the data, he can't delete the data. Even though he wants to delete the data, he has to have certain permissions from the administrator, or else he can't change the data, existing data, until and unless he takes the permission. So, there are certain roles for each and every identified group, and those roles should be well defined. So, for each and every role we must identify the parts of the database for which the permissions needs to be given. So, these particular permissions are called as the access permissions, access rights, and then you have to identify and you have to provide only those privileges for the groups. After taking care of the security design part, then comes the tuning part. Tuning part is nothing but a balance taking part, wherein which the complete study of the overall 6-step processes needs to be taken care. If everything is well, it is well and good, otherwise the whole thing needs to be tuned in such a way that the database works efficiently and give the promising requirements or promising things that the user wants. So, before concluding this session, let us have a recap. In this particular session, we had studied about the relational databases, which is the popular model, and later on we had seen the overall design of a relational database design, what are the steps involved in it, and what are the necessary tasks in each and every phase one has to do. So, with this I hope you understood the session. Thank you.